I want to talk in this optional video about roots. Originally, I planned on talking about roots more in class, but as I was thinking about it, I don't think we need to worry about them too much for what we are doing in class this semester. If we were working with equations that were not primarily linear equations, roots would be more important than I think we have to worry about. So I'm making this video for it to be optional for people. Here's who should watch it. If you plan on taking college algebra, understanding roots well is an important prerequisite for college algebra. So if college algebra is in your math future, and I hope it is, this is probably a good video to watch. If you're transferring somewhere that needs finite math as one of your requirements, I would watch this there as in that case as well. This is probably section 1.2 of your textbook. It kind of depends on what semester you're taking the class and stuff like that, but it's part of 1.2. If you're watching this in the fall of 2020, it's definitely in 1.2. Remember that we can take the square root of any non-negative number, and here we have that in interval notation. So we take the square root of 0, and we take the square root of any non-negative number, so all the ways it approaches infinity. A square root is the number that times itself equals the number we're taking the square root of. That number is called the radicand. So for example, if we are taking the square root of 49, we're looking for what number times itself equals 49, which of course is either 7 or -7. The number under the radical sign is called the radicand. It's a fun little fact. And again, most square roots have two answers, a positive and a negative answer, because 7 times 7 is 49. But -7 times -7 is also 49. In those cases, when we talk about the principal square root, which here means the main square root, we're talking about the positive square root. So technically, the square root of 25, we often write it like this, plus or minus 5, because both 5 times 5 and -5 times -5 equal 25. So but the principal square root of 25 is 5. In this class, unless you're ever told otherwise, we are only be interested in the principal square roots of things. On the other hand, if you're in a class where you're dealing with quadratic equations or others, other than strictly linear, and you're doing more things with square roots, there may be times when you're going to be definitely interested in things beyond just the principal square root. Now, unlike square roots where the number can only be non-negative, we can take cube roots of any number. So the cube root, for example, of -27. We couldn't find the square root of -27. The square root of -27 doesn't exist as a real number. And remember, in finite math, we are considering only real numbers. We're ignoring imaginary numbers. So the cube root of -27 is -3, because -3 times -3 times -3 is -27. Or we could say the quantity -3 cubed is -27. Roots are inverses of exponents. Taking the root is the inverse of finding the exponent. We could say that taking the root undoes an exponent, just like division undoes multiplication. Or we could say that multiplication undoes division. So for example, since 4 cubed equals 64, because 4 times 4 times 4 is 64, the cube root of 64 equals 4. So it's not just cube roots. We can take any odd root, a 5th root, a 7th root, a 9th root, an 11th root, a 21st root, a 99th root of any number, negative, positive, or 0. But even roots, square roots, 4th roots, 6th roots, 8th roots, and so on, of only non-negative numbers. In other words, only 0 and the positive numbers. And of course, any root of 0 is always going to be 0, so that's really a mostly unimportant case. It's very trivial. So for example, the 5th root of 32 is 2, because 2 to the 5th is 32. The 4th root of 625 is 5, because 5 to the 4th is 625. The seventh root of negative 128 is negative 2, because if we took negative 2 to the seventh power, or the quantity negative 2 to the seventh power, we would have negative 128. How do we find roots on the calculator? So there's a square root button on your calculator that's easy to get to, relatively easy to get to. Let's take a look at that actually here. Pretty sure my calculator is still up. So to find the square root of a number, we hit the second key and the x squared key, and we see above that there's a square root symbol, a radical sign. So to take the square root of 25, we do like that, and we hit enter. And the calculator only gives us the principal square root. But how do we find a third root of 25, or the 12th root of 25, or the 18th root of 25? In a case like that, we have to use the math menu. To get to the math menu, we start by pushing the math button, which doesn't show there actually. The math button is this button right here on the calculator screen, right above x to the negative 1, which is also called the inverse button. When we hit the math button, we go to the math menu. The math menu is very powerful, gives us lots of possibilities of things that that we can work with. I go over here. Then what we want to do is we want to go down and we want to choose this option right here, option 5. Now there's a special one for finding cube roots, because cube roots are really the most common roots people find are square roots, of course. You almost certainly learned how to find square roots in math courses in high school, maybe even middle school. Cube roots are the second most common, and again, almost certainly you had to find at least a few cube roots in past math classes. But the calculator lets us find any root. And so we call this an xth root. So by choosing option 5, we get this sort of funky looking screen. There's 2 places for us to put a number. In this flashing box, sort of inside the hook of the radical sign, we put whatever the root is we want to find. So let's find the 10th root of 25. And then we just use the arrow keys to move to where the radicand is. And then we type in what we want our radicand to be. And then we hit enter. So the 10th root of 25 is approximately 1.37973. In other words, if we took 1.37973 and we raised it to the 10th power, we would have approximately 25. Notice it's not exactly 25 because we rounded. But it's 25 to 3 decimal places. So that's fairly good for a rounding. So here on the calculator, on this example, I took the cube root of negative 125. So on the right-hand side, you can see the actual keys that I pressed. So first I hit the math key to get to the math menu. Then I hit the cursor key down to get to the xth root. I hit enter. I entered a 3. I entered a negative sign. I entered 125. I think it's easier just to show it. So math. And again, here, since it's a cube root, you could just choose option 4. That would also work. That would work just fine. But we went to here, enter a 3, enter negative 125, making sure to use the negative key, and we get negative 5. Now, your TI-84 handles, obviously, all this perfectly well. Not every calculator does. One cool thing, not really, maybe cool isn't the right word, roots and exponents, as I mentioned, are inverses of each other. One undoes the other. And what this means is that we can write any root as an exponent. We could write any exponent as a root as well, more or less. A square root is the same as raising something to the 1/2 power. A cube root is the same as raising something to the 1/3 power. A 12th root would be raising something to the 1/12 power. And so in general, if we have some variable x that was raised to the m over n, that's the same as the nth root of x to the m. And one of the things this lets us do is really quickly find roots on the calculator by using exponents. So including calculators that don't have or are trickier to get to the X root buttons. If I wanted to find the cube root of -27, I can just enter -27 in parentheses, because I need to include that negative sign with it, and then raise it to the 1/3 power. And I get -3. This also works with square roots. If I wanted to find the square root of 16, I could take 16 to the 1/2. And I would say the square root of 16 is 4. Again, the principal square root. So here's some examples I just did. One more trickier example. These are sometimes found in your textbook. So if you had 16 over 625 to the 1/4, if we were doing this by hand, we would see that's sort of the 4th power of 16 divided by the 4th power of 625. Or sorry, the 4th root of 16, my bad, the 4th root of 16 divided by the 4th root of 625, which is 2/5. It is, and these are pretty common 4th roots, but in the meantime, until you get those memorized, it is probably quicker to just take that fraction and take it to the 1/4 power, and we get 0.4, which is the same as 2/5. Again, this isn't a great example because 2/4 we know is 1/2. But in general, if you weren't using a calculator, and again, in my classes, you can always, or 99.5% of the time, use a calculator. You might eventually take a class where that's not true for various reasons, including, obviously, we want you to understand what's going on, not just rely only on the calculator. So in a case like this, you could do this in one of two ways. If you have some number like this raised to some fractional exponent, whatever the denominator is the index of your root. It's the root you're taking this to. So you're taking it to the fourth root. And then you could do the other thing one of two ways. You could first take the radicand and square it here because it's squared. Or you could find the 4th root of the radicand first, and then you could square your result. Sometimes one approach or the other is going to be quicker. Remember that negative exponents mean basically that if it's an integer with a negative fractional exponent, we are going to switch the position of the integer. If it is an integer by itself, like here, like here, we're going to move it to the denominator. We're going to put it under 1. And we're then going to change the exponent to be positive. And then we would go from there and say, oh, this is one way to do this is the cube root of 8, and then we're going to square the result. We get 1/4. Again, we could also just do this in the calculator by plugging in on the calculator, going 8 exponent key -2 divided by 3, and we would get, on the calculator, we get 0.25, which is, of course, 1/4. If you remember, if you're taking a fraction to a negative power, what you end up doing is flipping the fraction. So, and then changing the power from negative to positive. So 25 over 16 to the -3/2 is the same as 16 over 25 to the +3/2. And so that would be the same as finding the square root of 16 divided by the square root of 5, and then cubing the answer, which is going to be 64 over 125. If you took math for liberal arts, or if you remember things from high school math, you may have had to simplify square roots, and there are some pitfalls with that I want to point out. The square root of a product is equal to the product of the square roots. Let's fix that typo. So the square root of the product A times B is the same as the square root of A times the square root of B. And we use this fact to simplify some square roots. We can simplify the square root of 20 this way, because the square root of 20 is the same as the square root of 4 times 5, which is the same as the square root of 4 times the square root of 5. And 4, of course, is a perfect square, so we know that the square root of 4 is just 2. So the square root of 20 equals 2 times the square root of 5. This does not work for addition. The square root of a plus b is not the same as the square root of a plus the square root of b. Similarly, the quantity x plus y squared is not the same as x squared plus y squared. Be cautious about those sorts of mistakes. So let's finally use exponents in an application problem. This comes from the textbook being used this semester. It took 150,000 work hours to build the first Boeing 707 airliner. Later planes took a lot less time to build. And this is true for lots of things. The first thing takes a long time to make, but over time, as expertise increases, as bugs in the system get worked out and other things, the time decreases. And we have a formula here. The formula to build a plane in work hours is 150 n to the negative 0.322 thousand work hours. And so for the first plane, we replace n with 1, and what we end up with is 150,000. How long would it take us to make the fifth plane? Here, we've replaced n with 5. So what we would have is 150, that's supposed to be a 0, times 5 to the negative 0.322. Remember PEMDAS from previous math courses. Remember order of operations. We do exponents before we multiply. And so here, the first thing we have to do is raise 5 to the negative 0.322. Then we're going to multiply that answer by 150. So we're going to use the calculator to do this, obviously. So 5 to the negative 0.322 is this decimal times 150. Now we can multiply. And we get about 89.34. 89.34 thousand work hours to make the fifth plane. And we see that calculator screen there again. So the calculator, if you're using a TI-84, is smart enough to do order of operations, but it is always important that you be smarter than your calculator, just to make sure that you could break those steps apart if you had to, because sometimes a calculator will surprise us in what it does, even a powerful one. Let's do the same thing for the 10th plane. So here we're going to replace n with 10. And so when we multiply this all together, we get about 71.46 thousand work hours. So people might ask, why would you ever use a negative exponent? That's a completely reasonable answer. It's one of those things that people think of mathematicians as only being interested in pure math and not in the real world. But math is used to model things in the real world. And whether a person is an economist or a social scientist, a biologist, a demographer, working in many, many different fields, we use math to model. And sometimes those models, in fact, do involve things like negative exponents, as is the case for building airplanes in this case. Again, for most of what you do in finite math, with me, because of the way the course is structured, we're working primarily with linear equations, except when we deal with some things of interest. And so we aren't going to worry a lot about roots. But again, this would be a nice preview for future math classes. Or if you are going someplace that requires finite, particularly if their finite includes a lot of work, or really any work with quadratic equations or cubic equations, or with exponential or polynomial functions of some sort. So if you do have questions about this, just let me know. I'll gladly talk about it with you or talk something through if you don't understand something. Again, more of this information is in your book. I also put up supplemental videos from the internet about it in the course, because originally we were going to spend class time on it. But I think it's a good thing. I think it's an appropriate thing for us to leave as optional for those of you who might need it or who might be interested in it. Have a great day.